Hey everyone. So today I participated in weekly contest 310 and so I have solved all the four problems. So in this video I'll be discussing the solutions to these four problems. So let's get started with the first one. So basically what you're given is you have a array, integer array, and you have to find out the most frequent even element. So the number should be even and it should occur the max number of time among all such even numbers. And if there are multiple, such even numbers, and that means there's a tie, then you return the smallest one. And if there is no such element, you return a minus one, right? So there could be multiple ways you can do this question. So this is actually an easy problem. So how I did it was I used a hash map, and so basically I stored all the numbers in a hash map, and then I loop over my hash map and check if the number is even and the frequency of that number is greater than current max frequency. So this current max initially is set to 0. So if this condition is satisfied, then I update my answer. Then I update my number and the frequency as well. So since C++ map is sorted, this map is sorted. So basically, so in case of tie breaks, you'll first go to the smaller element. So in that case, that smaller number will, you know, uh, put the effect, and the larger number will not be able to do so. So yeah, so that's about the first problem. Nothing fancy. You can do it in multiple ways. This is one of the way I did it. Moving to the second problem. So basically, you have a string, and you have to break this string into multiple substrings. So basically, you have to do that in such a way that each substring formed is actually has actually unique characters. So there should be no duplicates. So basically, ABA. So if you break this is not a valid string because there's a repetition of A, right? So the way you do this is and the condition says that you have to do this in minimum number of partitions. Otherwise, you could just split it every character. You can just split it every character, and all the characters will satisfy. So yeah, you have to make sure that the partitions are minimum. And the way you do this is it's basically a greedy problem. So you try to uh, you know try to go right as much as possible, and if there's a conflict, so you start from A, you go as right as possible. If there's a conflict, yes, there's a conflict because you have a, so you break. So this is one substring. Then you start again from here, and you follow the same process. So it's a greedy. So basically, you start from the left, and then you look for the first character which disturbs the current string. So you have to break there. And the way I did this is, if I go to my submission, I used a map. And so what I'm doing is, okay, I'm looping over the actual string, and I'm checking if the current character is already present in my map. If it is already present, then I need to increase my answer because I have to do a partition now, right? So I've done a partition at the previous character. So this current character will now go to the next partition. And I reset my map to an empty map, and I always put my current character into the map, right? So if this is not clear, like I'll just quickly take this example. So basically, you have ABA, CABA. So you have ABA, CABA. Okay, right? So initially, my map is empty, and so I move from this side. So now my map will have A, then it will have a B. Then I check for A. So I'll say that A is already present in my map. So I need to break here, right? So I'll clear my map. So this is now clear, and again it will reset, and I'll put my A. So this is my new state. So I proceed again. I'll put my C, and then I'll check A is present. Yes, it is present. So I need to again clear my map, and this is another split. So my map is cleared again, and again I have to start putting one by one A. Then I check, is B present? No. So I put B. Then I check, is A present? Yes. So I have to clear my map again. Then again I'll put A, and finally I'll exit from my string, and finally I'll say that there is something left in the map, so I'll do a +1. So 1, 1, 1, and 1. So that gives me an answer of 4. So yeah, that's what this problem says, and this is also not very difficult to implement. So yeah, um, let's move to the next problem. So in the next problem, what you are given is, so if I go to code here, so you have a set of intervals. So you have a set of intervals, and what you have to do is you have to split these intervals into some number of sets in such a way that each set, the set of intervals in each set does not conflict with each other. So when I say conflict, it means that they intersect. So these two intervals, they are conflicting. So this region, if you think about this region is a region of conflict, right? Um, Again, so they are saying that the endpoints are included. So even if they're touching like this is again a conflict, right? Because they are conflicting at the endpoint. So in this case, if you think about this, you can split these three into two intervals. You can take these two into one group, right? And this in the other group, because these two are not conflicting. This was conflicting with both of them, and so you put this into set B and these two into set A. So the answer for this would be 2, because you will have to make two different sets. If you think about this, then this is nothing but basically you have to find out the max number of intervals that are conflicting at any point, right? So basically, if I take an example, take this, let's say this, and I have this. So somewhere around this line, you can see that these four intervals are intersecting. So now I cannot put any of these two in a same group. So I'll require four different sets, right? So if you think about this, then yeah, this should be your answer. So if you have like this conflict or some other conflict, like this conflict, okay, for this conflict also we'll have four. So let's not take this one. Let's take something else. Let's take this. So this is 4. Here you have 3. Here some, let's say, okay, let me just redraw this. So here also you have 3, and somewhere here also you have 3, right? So this is the maximum you can get. So 4 is a maximum, intersection at any point. Because like this one, since this one does not intersect with this one, you can just put this one with this in the same set. So the answer is still same. So the answer is maximum of all those intersections. So and the way you do this is so there's an easy way and there's a tough way. The tough way is you use some complicated data structure like segment tree, and you do range updates and check if the ranges are overlapping or not. I mean, I used to do that initially until I got to know about the approach which I used in this contest. So yeah, so this is actually a very simple approach. So what you do is you have so you maintain vector and vector. So what you do is you'll push all the start points of every interval with some number. So I use 0 for start point, and then the endpoints also you push in the same vector with a different number. So these numbers actually will help you identify that which point is a start point and which is an end point. Now you sort all your these points, and there's a reason why I put 0 and 1 here, why this number is less than this number, because I want all my start intervals to occur before end intervals in case of tie breaks, right? So what I mean by that is, okay, let's say, let's think about this. So let's say these, I have two intervals. Let's say this is 2, this is 3, this is 3, and this is 5. These are like points. Uh, so in my vector, I'll have 2 comma 0. I'll have 3 comma 1 for this. I'll have 3 comma 0 for this, and I'll have what, 5 comma 1, because this is an exit point. So so my sorting order which I want is, it should be like 2 0, 3 0, 3 1, and 5 1. Now why do I want that? Because so when I loop from this side, I'm going to keep track of how many open intervals are there right now, right? So 0 will tell me how that it's an open interval. So so far it's 1, here it will become 2, and you can see that this is correct. So till here it was 1, and here it becomes 2, because the endpoints are included, right? And then it decreases. Then I'm taking the effect of this endpoint, right? So if I take effect of this before the effect of this, then it would be wrong, because you'll have this here and this here, and so 1 0 1 0. So it will tell me answer is 1, right? In that case. So this is why you put a 0, a smaller number with the open interval, so that you, in case of tie breaks, you take the effect of open interval first, right? So yeah, that's a really nice trick I learned some time back. So yeah, and then there's nothing left. So, like, you sort all the numbers, and then you check if the current interval is open interval, then you just increment your open. Otherwise, it was a closed interval. You decrement the open, and finally your answer would be at every point, what's the max number of interval open. So yeah, that's the third problem. So this was also a standard problem, I think. So then going to the last problem. So the last problem also is a variation of a standard problem, if I say. So basically you have a long LIS, and what you have to do is you have to form the longest increasing subsequence, such that first of all, it should be strictly increasing. There should be no consecutive equal elements. And then the difference between any two consecutive elements should be at most k. So this is the special condition. Like, if you talk about standard LIS, then you don't have this restriction of at most k. And the way I did this is I used a data structure to maintain what's the max LIS ending at a given number, right? So I use a segment tree. And so, like, before that, let's just take an example and try to see how this will work with a segment tree. So I'll just clear this, and let's take this same example. So you have 4 2 1, 4 3 4, 5 8, and 15, right? So the way you do this is for the first element, you cannot do this. You cannot do more than one. So your answer so far would be 1. For 2, you'll check. Okay, so before that, you are also given k equals to 3, right? So let's write this as well. So you have k equals to 3. So for 2, so ending at 2, so we want some number before it, and that number should not differ by more than 3. So for 2, you don't have any such element, so your answer would still remain 1, because this is the only element. For 1, again, your answer would be 1, because there's no element smaller than 1 with maximum difference 3. For this 4, you'll say that you have 1, which is smaller than 4, and the absolute difference, 4 minus 1 is 3, which is less than equal to your k, right? So this can come before it, and this 2 also can come before it. And so you will take max of these two. So the answer in case of these two was 1 and 1, so it doesn't matter which one you take. So you take max of those two, and you will do a plus 1, because you're including the current element as well. So that would be 2 in this case. So for 3, you can take a 1, or you can take a 2, because these two satisfy the condition, this k equals to 3. And the max again is 1 and 1. So again, max of these two is 1, and you do a plus 1 because you're including the current element. For 4, you have multiple options. You have 3, you have 1, and you have 2. And the max among these 3 would be your 2. So you take the max and do a plus 1 because you're including the current element. So that would be 3. For 5, you'll have this 4, 3. You have all these elements, right? So you take max of all these, which is 3, and do a plus 1. So your answer so far is 4. And for this, you have all these. So not all these, sorry. So you'll have only this element because all these elements will not satisfy this condition of k, right? So 8 minus 5 is 3, so that will satisfy. So you do max of this, which is nothing, it's this itself. So you do a plus 1. So your answer is 5 here. For 15, there is no such element which satisfies the condition of k, and so you'll end up with a 1, which is this number itself. So you can see that ending at 8, you can get an answer of 5, right? So this is how the answer for this test case is 5. Now, how I use the segment tree, I think you can use some of the data structure as well, but I use a segment tree. So you can maintain for each number, what's the max ending at that number, right? So if I go to the summation, I had an incorrect summation for this, which I'll discuss in a bit. Okay, so what I did was I know the maximum value a number can have is 10 power 5. So I have a segment tree of that range from 0 to 10 power 5. And what I do is initially I'm setting my answer to 1. This I'm doing manually. So for the first number, I'm setting the maximum length equal to 1 in my segment tree. So I have two methods, which is one is update and one is get. So the segment tree is get maximum in a range, and you can do point updates. So you start from the second element, and then you say if the second element is a 1, then you continue. I'm doing this update because for number 1, answer is always 1. There could be no before element to 1 because the range is 1 to 10 power 5. Otherwise, what you do is you check what is the maximum value from current number minus 1 till current number minus k, right? So you take the maximum value and your answer would be updated to your current max, comma, the maximum value you can get plus 1. And again, like you'll update for current number what the maximum answer is. So the current number is nums of I, and then you update max c plus 1 to your segment tree. Now, so this is again like not so hard problem, a variation of standard one, so fairly simple to do. So my penalty came in the form that I missed a base case. I was handling n equals, so number equal to 1 especially, and then I was not updating for n equal to 1. So yeah, that's for the contest.